What's up guys, how are you all doing? Today we'll be attempting to make one of the most important electrical equipment in any kind of devices, a rectifier. But what the heck is a rectifier? You see, a rectifier is a device that converts a messy and unstable alternative current, which is an AC, into a more stable current, which is known as DC. So this to this. Yeah, but how the heck does it do that? You see, a rectifier is usually made of one component, this. This is a diode, typically a high performance diode. Component, which is a diode, is to let only one direction flow of current. This is the simplest definition, to be honest. Okay, this is the classic demonstration of a simple circuit connect to an alternative current source. Now, when we apply voltage through this circuit, if we probe, for example, right here, if we will read such kind of graph, it's just like this. It's a classic graph of an AC circuit, which indicates that this one is positive and this one is negative. Anyway, now moving on, we all know that a diode only lets one direction flow of current, which means the current can go through here, but it cannot go back through the same wire. Which means after this, if we measure the probe right here, we will get this kind of graph. The positive side is conductive and the negative side isn't. So there is no conduction in the negative side, which means it may rise up and it may go down. This would be a phantom line, which means it doesn't exist. And when it reaches zero, it becomes up, then down, then phantom, and the like. Just like this. We call this a half wave rectification. You got that? Still, the rectification that we want is just like this, right? We want this kind. If this is the zero, we want a direct current, which is like this, or closely like this. And this is not this. So we need to add more components to the system. So yeah, what shall I do? And now I realize that instead of kind of wasting my time in something that is very common, yeah, I can just simply Google. So by doing some more research, we can connect 4 diodes in such manner and we'll make something called a bridge rectifier. I wonder why it's called a bridge. Moving on. Now let's try to find out what kind of current it outputs. Now, as we know, an AC creates a 2-directional varying current, which means it goes in and it goes out, in and out, in and out. Current is going through here, for example. It's just going through here, and the only way it can go, by the way, this is positive, it will travel through here, which is the positive, just like this. One way, only this way. So as current go through here, the current rises just like this. Alright, we have found the half cycle. Now, in another interval, if we think this is, for example, negative, and if this is the positive, and if we imagine that the current is flowing through here, it goes here, here, and the only way it can get in is through here. So yeah, so we're gonna put it just like this, rise and down. And the cycle repeats. Eventually, it becomes this bumpy cheeks right here. So yeah, this is what we call a full wave rectifier. So yeah, seems easy, right? Yeah, but not quite. Earlier I said that what I wanted was this direct straight line of DC current. This is no straight line. Okay, and another thing that I found is this. By adding a capacitor, it will make it smooth, you know? You can make many dirty words. So the new waveform is gonna be just like this. Okay, it's gonna be bumpy, but this is the waveform that it should look like. So yeah, this is how a full bridge rectifier works with a capacitor. So yeah, it was relatively easy, right? Yeah, same. So yeah, now without further ado, let us bring this circuit to life. This is the schematic of the circuit that I'm gonna make. Okay guys, now I've made the bridge rectifier just like this. Here is the main outlet, and here are the bridge diamond shaped diodes and parallel connected to this Beautiful capacitor. Now, let's turn it on. There's a little bit vibrational sound. I don't know if you guys can hear it, but it vibrates a little. And it's getting hot. I don't want to touch it. Now, there's a little problem. You see, this diode only accepts until about 3 amps. 3 amps, imagine that. Now, because of the 3 amps that I was talking about, I may not be able to draw that much current if I want to. But imagine it. This creates a 311 volts with a 3 okay, if we say about 3 amps, each about 0.7, which is about 2 something amps, 2.5 maybe, I don't know. Such kind of amp, for the time being, I can't use this on anything, to be honest, because the voltage is too high, like 311 or something. I need something to add, some components to add on this circuit if I want it to function for a specific purpose. I just remembered that we can add a transformer to the system. You see, a transformer, its entire purpose is to convert power, right? Yeah, but this transformer's rating is important. For example, if we use a transformer for like 12 watts, and that is the only energy we're gonna get. So instead of making a new diode, a new capacitor, and a new transformer, instead I've plugged this system, this circuit, this beautiful circuit, inside an old radio. Using Rectifier, you can do many things, just like lighting a bulb. Oh shit. There we go. Using a rectifier, you can build your own power supply. But for the time being, this is what a rectifier does. If you see any kind of schematic of any device, for example, a power supply, a phone, a charger, any kind, it always have a full bridge rectifier. This is more or less what rectifier does. Yeah, pretty neat. And I hope you build your own as well. And finally, don't forget to share, subscribe, and comment your thoughts about this, and see you next time.